Bismillahirrahmanirrahim. So, the topic for this lecture is sinusoids. So, a sinusoid is a signal voltage or current which is in the form of a sine or cosine function. A sinusoid is a signal that is voltage or current which is in the form of a sine or cosine function, right? So, for example, we can have a sine function like this, sine waveform like this, right? Or we can have a cosine function, cosine waveform, uh, which is, for example, like this. So both these signal shapes, these are sinusoidal functions, right? So, for example, let's consider on this axis, let's have a t, and this is v of t or I of t, depending upon the situation. So let's consider a sinusoidal function. V of t is equal to Vm sine omega t, right? So we can plot this function like this here. Let me plot this again, specifying Vm, and on this axis we have a t. This is a v of t here, right? And this is a sinusoidal function, right? So this is the peak value, and this is the negative peak value here, right? So we have this. So this is a sinusoid, right? So this is the peak value Vm, and this is minus Vm here. So this is the amplitude or the peak value, amplitude, right? Omega is the angular frequency, and t is time. Note that time is measured in seconds and omega is measured in radians per second. So omega is in radians per second and t is in seconds. So the dimension of this argument omega t is just radians, right? Which is unitless, dimensionless. So this argument here is dimensionless. So as you can see, this is a periodic signal. If we start from here and till here, we complete one cycle, and then this pattern, it starts repeating from here again. So this is a periodic signal, and this is the time period. This is the one cycle here, and at time t is equal to capital T here, we have this time period of this periodic signal, right? And this is t by 2, half of the time period, right? And similarly, for example, we have 2t here, right, at this point. So sinusoid is a periodic signal in this form here, this Vm sine omega t, and this omega here, as I told you, is an angular frequency, and it is given by omega is equal to 2 pi f, where f is in cycles per seconds or hertz, right? And we also know that f is 1 over t, right? So we can write this omega is equal to 2 pi over t, right? Uh, t is equal to 2 pi over omega. So we can write down, we can actually take this axis along omega t also, for example. So let me redraw this here again. So here we have now omega t, right? And we have v of t here, right? And when t is equal to 0, when, for example, t is equal to 0 here, then omega t is obviously 0, right? And when t by 2 here at this point, when t is time period divided by 2, then omega t is, remember, omega is 2 pi over t, right? So this is 2 pi over t multiplied by t is equal to capital T over 2. So that is just pi. So omega is equal to pi, omega t is equal to pi here, right? So this is pi here. And when t is equal to capital T, then omega t is 2 pi over t multiplied by just t, that is simply equal to 2 pi. So this is 2 pi here, right? So uh, this is a periodic signal with period t is equal to 2 pi, right? Now let's consider a more general form of this uh, periodic signal. So let's assume Vt is equal to Vm sine omega t plus phi. This phi here is called the phase angle or phase shift, right? So this can better be understood if we compare this plot here and the plot for this signal here, right? So for example, let me say this signal here was V1 of t, V1t is equal to Vm sine omega t, and this is, suppose, V2t here, Vm sine omega t plus phi, right? So the plot for this one is simple, like before. We have here, right? This is V1t, and omega t plus phi. If we plot it, it will be something like this, right? So this is V2 of t. So if you note that when omega t plus phi is equal to 0, so then sine 0 is 0. So it is this value here, right? So when omega t plus phi is 0, so then basically omega t is equal to minus phi. So along this axis we have omega t. So omega t is equal to minus phi here, right? And this is 0 here. So this difference here is basically the phase angle, right? And we say that this V2 leads V1 by phase angle phi. So if you see, this value 0 for V2 occurs before the value 0 for this signal here. So this occurs before this signal, for this signal V1. So we say that V2 leads V1. Likewise, this peak value here for V2 occurs before it occurs for V1. So again, we say that V2 leads V1. And also from here we see that we have a positive plus sign here, and if we compare both of them, so we say that v2 leads v1 by phase angle phi, right? So if you want to compare two sinusoids, whether uh, a sinusoid leads the other sinusoids or lags the other sinusoid, we must formulate both the sinusoids in a similar form. For example, both the sinusoids must be either in the form of sine or in the form of cosine, both of them, right? And then this sign here, the both of them, they must be positive or they must both be negative. And third, the angular frequency of both the sinusoids must be the same for the comparison to take place. So that's it for the sinusoids.